Hello, everyone. So, just want to raise the energy a little bit. We come to the very last sessions of, almost the very last sessions. After me, there will be my former boss from Shetan. He's the head of AI for Hitachi. And I'm making him very proud, so I moved to FPT and become the chief AI of FPT. And so together with me today, I would like to introduce Dr. Nghi Bui. Please join me on the stage. He's the head of our lab for software department. And he's also the research manager at the Intelligent Software Lab X in Singapore Management University. And together we do a lot of exciting tech for generative AI, especially in the industry of software engineering. So I just really want to share a little bit about FPT. Many of you here may come from Vietnam, and so maybe you have heard about the name FPT, but many of you here may have not heard about it. We are actually the largest tech corporation in Vietnam, and FPT Software has almost 30,000 employees. Most of them are engineers and developers. And we're working as one of the destination for software outsourcing projects. And my responsibility, I managed an AI center within FPT Software. We do a lot of research and development, and we do a lot of solutions for the customers as well. So this is my team. We have around 1,000 people in my lab right now, and they have different roles from scientists to engineers, and these are some of the experts that I have built over the past few years. And we do a lot of cutting-edge research. We publish in the top tier conference like ICML, NeurIPS, and those are extremely prestigious and difficult to publish in AI. And we also have patents and IP in the domain of AI as well. So our two main focus at the moment is AI for software and AI for industry. Why is this true? First thing is software itself is an industry, even though software enables a lot of other industry, but software itself is an industry. And we have heard a lot of presentation today, like how people use generative AI to help software industry. And we are also the one that focusing our strength and efforts in making this happen, because we have 30,000 engineers to be our very first customers. And we also have a lot of connections. 30% of the revenue of our 1 billion revenue is actually coming from manufacturing, automotive. So AI for industry is also the other focus that I am focusing on. One is mostly for internal use, and another one is to enable the customers. So I would like to give the stage to Dr. Nghi to share with you a deeper technical knowledge about how we use generative AI in software engineering.
So I would like to share a bit about our ecosystem on AI for software and some background on why we do AI for software at FPT. So we may start with some concept of software 1.0 and software 2.0, right? So if you know Andre Kapati from the director of AI at Tesla, so he had a blog post and say something about the software 2.0. And compared with the software 1.0. So basically, software 1.0 is just what we are familiar with, right? We write software, we write backend, we write mobile application, we write front-end application. But software 2.0 is more like we ask the AI model to write the software for us, so, right? It's simply like that, right? So he talked about a lot. I think you can search about software 2.0 from Andre Kapati blog post to know about software 2.0 in his concept. So software 2.0, it has different meaning. I mean, different people use different terms. It can be intelligent software, it can be machine programming, it can be AI for software, it can be automated programming, right? So, but the key idea here is that it's about the automation of software development, right? So There is an article recently that they trying to break down the ChatGPT prompts. So they see that the 30% of the prompt is mostly about programming, using ChatGPT for programming assistant. So we can see that the use case of programming on ChatGPT is quite a lot recently comparing to another use case. For example, sales, marketing, content, education, things like that. But programming consumes a lot of inside the whole big picture. Right. So if you are, I believe that each and any one of us here have are writing code, right? So when we're writing software, we create a lot of data around the software development life cycle, such as the some user business data and some developer data or code data, right? So all of these data, a lot conform into some kind of and store into GitHub, Bitbucket, Stack Overflow, things like that, and we call it big data of code or short, or you can call that big code, right? So we have a lot of data recently throughout the software development lifecycle. So, so this is the inflection point of AI for software with the two conditions, right? So the first one is the rise of generative AI, like transformer, GPT, code large language model, right? And we have a new improved hardware like GPU, TPU, FPGA, things like that. And the most important is that we have large code base data set. So we call it big code. If you look into the data set of GitHub from 2008 and 2018, right? We see that from 33K repos to million repos, right? Which means that we have a lot of source code available online, which can be used for the data set that can be trained using Code LM recently, like ChatGPT and Code Llama from Meta, Facebook, right? So most of them, they're using GitHub data for training their own LM models for coding. If you look into the social media, we can see that, okay, people are talking about using AI to solve software engineering problem. Like IBM CodeNet, they are trying to solve the global migration using generative AI. Salesforce introduced the Einstein for Salesforce developer. Amazon Code Guru using AI to optimize application performance with ML power recommendation, right? Right, and GitHub Copilot, everyone is knowing GitHub Copilot at the moment, right? So that's all about AI for software, using AI to solve the software engineering problem, right? So if we look at the AI for software from the software developer perspective, we can see that they have pain point, right? So we split the software developer into three kinds, right? So we have low-code developer, junior developer, and experienced developer, right? So for low-code developer, they are just someone that want to create apps for a specific platform, but doesn't want to spend hours learning to code, right? And for junior developer, they just join the company. They can program, but doesn't fully understand code format of the company. For experienced developer, 2 or 3 years experience, right? They just want to avoid duplicate, repetitive, or basic level work that could be automated, right? So when coming to the AI for software solution, we can say that, okay, we can say that, okay, for code generation, for local developer, GitHub Copilot, right? We can use GitHub Copilot to automatically generate code for you. Instead of just you write the code by yourself, right? And another task is code summarization or text to SQL for someone that doesn't know how to write SQL code. They just write the description. And the AI model can generate the SQL code for themselves, right? For example, junior developer, they can have some advanced application like code shot, completion, anti-pattern detection, or code migration. For example, you look into the new project from the very old Java version, you want to upgrade it into the newer Java version. So for software can be a solution for you, right? And experienced developer, they want to do something more advanced like bug localization, automatically generate unit tests, root cause analysis, automatically refactoring your code base, things like that. So that could be something that software can do for you. Right. If you look into the industry investment on code large language model, we can see that the investment is started from 2020. Start from Microsoft, they have some GPT-C and by MT5. And if you look into the 2021, we have Codex from OpenAI, open source GPT, and we have Codify from Salesforce. But recently, we have Palm Coder from Google, and we have Encoder from Meta, and we have some famous model like Santa Coder from Hugging Face. So that's a huge big investment from Code LLM from the industry at the moment, right? So Code LLM is like large language model for code. So the abbreviated as a Code LLM. So we can see that in the recent trending, lots of companies using it for the actual applications, such as auto completion, generate auto boilerplate code, or security scanning, generate test case, explain code, refactoring, or UI development, right? So for example, Amazon are using Apple software for security scan. Salesforce is using autocomplete, their own model, code gen for auto completion, right? So in FPT software, we are trying to use for a wide range of model, wide range of applications such as test case generation, security scan, or code translation, right? Or detect anti-patterns. So different use cases, we can see that. So you may ask the question that what's the benefit, right? Of course, that we know that okay, we increase the productivity of software developer, things like that. But it's turned out that the real benefit is about software delivery, not about the productivity itself. Because productivity itself seems a bit ambiguous, right? So there's an article from GitHub to say that okay, AI for software is to enhance the software delivery, not about developer productivity, right? So this is the framework to measure the productivity, right? So they use different, so they call this the space metric. The space metric is to focus on, they split the productivity into different levels: system level, team level, and individual level. And each level, they have different focus, right? I think this framework is a bit too complicated to explain in this section. So maybe you can search through the internet to know more about the productivity metric. But this productivity metric is mostly about enhancing the software delivery and enablement, instead of just measure the productivity by itself, right? So at FPT Software, we want to build AI as a developer assistant for the whole software development life cycle. So the life cycle, usually, you can see that, okay, it's comprised of requirement, development, and testing, and maintenance. Of course, that for each company, you have some different phases, but mostly will be like this, right? You start with some requirement to writing some software, and you perform some coding, and you test the software, and you perform the maintenance, right? So in each of the phase, right, AI will have for each of the phase, right? For example, requirement, you can use AI to automate the requirement gathering from user feedback and analyzing user sentiment and feedback to prioritize requirement, things like that, right? For development, like GitHub Copilot, code generation from natural language description, right? For testing, you can use AI to automatically generate test case or predictive analytics to identify potential high-risk area of code, right? And for maintenance, you can use AI for software to monitoring software behavior real time and predicting potential future issue, right? It's like automatically bug fixing and program repair. Yeah, that's our whole development life cycle. Yeah, we perform a lot of investment on generative AI for software within 4 layers, right? For the foundation layer, we emphasize on the initial development of foundation model of code, such as code LLMs. Like for the second level, we focus on optimization of such model to address the issue like hallucination, ensuring trustworthiness, and establishing the benchmarking standard for software application. And the application layer, we use the code LLM model to solve the real problem in the industry, such as code generation, bug detection, program migration, software testing, things like that. And finally, right, once you have the application, how do you ship it for developer? It should be integrated inside a development environment, right? Such as the VS Code, IntelliJ, or some low-code, no-code platform for the developer to use, right? So that's the integration layer. So we invest in this 4 layer or the whole for software development lifecycle. Right. Right, this is the overview of our FPT Software platform. So basically, so we have a gateway, right? So the gateway um, can be a gateway to calling the API from the OpenAI, Anthropic AI, Cohere AI, and can be other AI, LLM provider in the future. So we can also including a custom SSM LLM in the gateway. So the gateway is designed to receive the information or prompting result from the large language model, right? So we have some, I think this is quite standard way to establish the platform. So our platform, one, we have the model, right? So we from some pre-processing, we have the vector store database, so we have some streaming batch processing job, and we have some application be on top. So we have like the programming assistant, the developer security platform, the language migration platform. So these are our three main application that is performing on our FPT Software platform, which is built upon the LM gateway, right? So that's basically our FPT Software platform. Yeah, this is one demo about AI assistant that we are using internally for our internal developer. Oh, that's a video, right? It's okay. Yeah, basically this is an IDE, Visual Studio Code, and we are trying to, the developer is coding on this side, right? And we have some chatbot on this side. So the chatbot is able to understand the whole code base of a developer, and then you can ask any question about the code base that the developer is working on. Something like, okay, how does this function work? How does the other function work? Things like that. Anything about your code base, and it will answer you and help you to write your code faster. Right? We are using that for our internal use case, and we are trying to make it more stable, and we will try to make it go to the public in very soon. Yeah. Right. So our case study is that, why do we do that? Because we have 30,000 developers. That's quite a lot of number, right? So we have 400 projects, and we have large-scale internal data set that we can use to fine-tune some custom model that no one have similar data set to ours, right? And we have a large, huge number of technical debt that we need to resolve, right? And I believe that most of the big company that we have the same issue. If you are a big company, if you are a small company, right, like 20, 30 developer, then this might not be the case. Maybe you can use GitHub Copilot for code generation, for developer productivity. But if you have a very huge number of developers like this, and you can increase the performance by 10%, that's the huge increase, right? So one question that you want to ask is that, how do we benchmarking our own model, right? Code LLMs. So in this paper published by OpenAI, so they're trying to conduct a benchmark called Human Advanced. So this Human Advanced benchmark is developed by human. So it comprises of some kind of coding problem and a solution, right? And they are trying to use the Pascal as the metric to, the Pascal, basically it's just the metric to measure the accuracy of the generated solution given the natural language description. I think we can understand simply like that, right? So this is the benchmark established by OpenAI 2 years ago, right? And people are competing on this benchmark. So you see that this is the list of model from the company like OpenAI, Salesforce, Google, they have the Palm Coder. Salesforce, they have the Code Gen model. Salesforce, they have another Code Gen smaller model. And Hugging Face, they have the Star Coder model, which is quite famous recently. Yeah, Microsoft, they have the Wizard Coder and V1, which is quite famous for the industry recently. So we have our own internal model, and if we compare it to stay up the art, right? So our model size is around 7 billion, and we reach the +1 accuracy around this number, which is still a bit far away from GPT-4, right? But most of the open source company, they are trying to reach this number and trying to surpass GPT-4 on the coding benchmark, right? That's we can reach this number, which is quite good use case for our internal use case already, right? So we are trying to build some other model that can be close to this number of GPT-4, right? That's our current state. We will try to release the model open source in the in the very near future. Yeah. So for the next stage, uh, you can see that, okay, we are talking about agent, right? So I believe that we will soon move to the stage that we are using agent to build our AI system instead of just one single model, right? We move from the predictive model, right, to generative model. And I believe that the future will be agent model, right? So there are some kind of paper recently that published about using agent to build software development framework, right? For example, you can see that this is the framework, so they call it Meta GPT. So they represent for the whole software development department of the whole company in a very collaborative process. You can just say, okay, this is the agent for requirement. This is an agent for system design. This is the agent for an agent as a project manager. This is the agent for coder. This is the agent for tester, right? Things like that. And these agents collaborate in the coding environment with the real user, and the user can interact with these agents to coding the software interactively, so that you don't need to write your code and design everything by yourself. So the agent will help you to finish your programming task, right? Right, so this is our agent-based framework for software development at FPT Software. Um, Basically, so each of these are the agent, right? So we have some kind of a tuner, right? The tuner is the LM agent that can be used, that are trying to use tune, right? So the tune are like how to ask question on Stack Overflow, how to use API from GitHub, how to use static analyzer, right? So the queues on the link, how to use library on the internet, right? So this is one agent that has been trained to use tune. And another agent that is has been trained to use to retrieve knowledge base from the code base, from the long short-term memory, right? And there will be another agent that is responsible for planning, decision, action, and before making the decision for the whole process, right? Taking that the developer is the center, and we have agent working around developer to help the developer perform the coding task faster, right? So this agent, we are working with the AI automatic to use the AI cam and the OpenSI framework to train the agent. So each of the agent is a small specialist model, right? That's that has been trained on the OpenSSA. So I believe that in the future, our agent with the OpenSSA framework, I think it will perform better and specialize in its own framework. Under our collaboration with AI Automatic recently. Yeah. Yeah, I think that's it.
Thank you. So you can see that like in the software world, right? Just like manufacturing, we have many processes, and each process require a very specialized way of dealing with delivery, right? And as a company, we specialize in delivery software to customers. So this is what we master. We go into a different niche in software that maybe big competitions like OpenAI, Microsoft, they won't bother go into. And we develop this by our developers and for our developers. So we really understand the problem in the software world and try to solve it. There's one last slide actually. I want to show there's a framework that to show that there's benefits for the customers where you can control the IP of your code base, because once we can develop the motors for the customers, the motor will be owned by the customer, not by us. So the IP will belong to the customers. And secondly, there's more and more demand to serve the software engineering AI platform in the system of the customers. So they don't want to send any code base to open source. Sorry, not to open source, to providers like OpenAI or Microsoft or Google, because they are worried about the IP and the leaking problem. So with this framework, we can help the customer to also not only us, but also the customers to protect their IP. So thank you very much for your attention, and I hope you enjoy our specialist model in software. So any questions?
So the question was, how do you deal with context window? Let's say the code base has 1 million lines and you need to write 1,000,001th line based on the previous 1,000,000 lines.
Yeah.
I know you guys were using some retrieval stuff. I was just curious about that. If you're using retrieval, how are you embedding code different than just normal text is a sub-question in that.
Yeah, thanks for the question. I think that's a very good question. So the solution that we are using is based on graph, knowledge graph, right? Basically, the knowledge graph is the one that represents how the code base is linked to each other, right? So for example, we have one function going to the other function, and what this function going to the another function, which can be represented as a whole graph, right? So we have some backend architecture to represent the whole code base as a knowledge graph, and we perform the retrieval on the knowledge graph to retrieve the context for the one that's relevant from the current user prompt. Yeah.
Is there any research on this that you're referencing to, or?
Yeah, that's quite a lot recently. Okay. Yeah.
Thank you.
And if anyone wants to see the demonstrations of how our code assistant helping the developers, we have a little booth next to AI Automatic right over there. And there's a screen I will show you because we don't have the screen.
Phong, I have a
yes,
question.
Shaitan.
Promise you won't ask me a question in return, okay? But how do you ensure that you're not violating copyright for the code?
Yeah.
So this, especially for industrial use cases, in fact, for any enterprise rather, that would be a big concern. I know someone is getting sued by someone for sure right now.
Yeah, thanks for the question. That's also the question that we keep asking our team to handle. I think one aspect that we are tackling on is that we are not training on the non-permissive. So for example, GitHub, right? So they have two kind of license: permissive license and non-permissive license. So basically, we filter out all of the data that have the non-permissive license, and we only train on the model that have the permissive license, right? So that's one way to ensure that the model is not trained on the data that is prohibited from using, right? That's one way. Another way is that we protect our user from some kind of security layer internally, and we make sure that for example, if the model generates the code that has not been that is violated to some so because we have some database internally to check if the code is violated with that database. If the code is generated and aligned with the database, then we say, okay, this is violated, and we do not show to the user, right? That's the perspective that we can tackle.
I have another follow-on question. Sort of so I understand it's quite easy to not easy. I mean, it's possible to generate code. One of the challenges that you have after that is when you are debugging someone else's code, and right. So even though you're saving on the development time, your debugging time goes up. So are there any sort of workarounds that, or is that something you've experienced in your own organization? Yeah, because you're not debugging your own code, right? You're debugging someone else's code, essentially.
Can you repeat your question? So, it's about debugging the code base using
you generate some code using whatever, right? Generative AI framework, that's your favorite. But now when you are finally testing and debugging, you're debugging someone else's code. It's not code that you wrote, correct? Because it is copied from someone else. As a result, your debugging time is going to go up, right? So two questions on that. So one, is that something that you have noticed in your own organization? And are there any tools that you're developing to work around that?
I think when we are trying to debugging someone else's code, basically if the code is if it is permissive, then there's no problem with that, right? So you ask about the security of the code, or
the time it takes to debug will go up, right? Because you did not write the code. You have to
right. I see, I see. So we have some kind, so we are researching on some kind of a cell reflection or cell correction debugging through the environment. For example, you are generating your code, right? We have some backend environment that can perform, that can execute the code automatically. Of course, the code can be failed. If the code is failed, you have some log, right? And we take the log and we feed back to the model again. And we say, okay, this code is failed. And we say, okay, if it's failed, then how do you, can you try to resolve the failure from the log again? So it takes multiple steps to make the code to be corrected from the cell reflection step. That's our internal research that we are doing.
Chetan, one more also. In the software world, right? The copyright is there's a few different type of things you look at in the software world. The first thing is IP in terms of like algorithms and applications level. Then that part is very hard for AI to copy the whole IP and give it to other people. And we will have the QA team to always double check. It's still human effort at the moment. Second is to check the license of the code to see if the code in the source code, is there any code that duplicated or copy from the source code that have license. That one, there are tools in the market like Black Duck and many other tools to check that, and it's going to give the flagging for the team.
Phong, thank you. I've worked with you, so I know I have a lot of confidence in what you're saying. Thank you.
Thank you.